In the last session, we were discussing about eddy current. Now here I have a question based on eddy current, and you can expect similar questions in the exam. Now first you take down the question. What are eddy currents? What are eddy currents? How are these minimized? How are these minimized? Mention two applications of eddy currents. Now we have discussed about eddy currents in detail in the previous session, so you can refer the previous video for the detailed explanation, but here I'll try to write answer. Now let me just recall. Now consider here two cases. In this I have shown a picture wherein a conductor is moved, or a bulk solid mass. A solid mass is moved in the presence of a stationary magnetic field. Now when this solid mass moves, the flux linking that changes and a circulating current is produced, and that circulating current is called as eddy current. Or it can be similar to this. Here there is a workpiece and you have an alternating current flowing through this coil. The coil produces flux, and that flux also links this workpiece and hence produces a circulating current, and that current is known as eddy current. So now let me write the answer here. When magnetic flux linked with a metallic conductor, in the form of solid mass changes, then induced current are set up in the conductor in the form of closed loops. Known as eddy currents. Let me read once again. When magnetic flux linked with a metallic conductor in the form of solid mass changes, then induced current are set up in the conductor in the form of closed loop, known as eddy currents. Or you can also write it as, I'll just write here, induced currents. Induced currents are set up in the conductor in the form of closed loop, known as eddy currents. Or you can simply write it as eddy currents are the currents induced in the bulk pieces of conductors when the amount of magnetic flux linked with the conductor changes. Okay. Eddy currents are the current induced in the bulk pieces of conductors when the amount of magnetic flux linked with the conductor changes. Now here is an example. Here is a bulk piece when this bulk piece is moved in a stationary magnetic field, the flux linking the piece changes and a circulating current is produced, and that current is called as eddy current. Now, how are these minimized? Though this eddy current cannot be eliminated completely, we can try to minimize it. So, eddy currents are minimized by taking laminated core. And what is this laminated core? It consists of thin metallic sheet insulated from one another. So, varnish can be used as an insulator. So, instead of solid single mass, you can take laminated core, and the plane of this sheet should be kept perpendicular to the direction of the currents, and here that insulation will provide the high resistance, and hence eddy current can get minimized. So, you can write the answer for the next question, how eddy current can be minimized. It cannot be eliminated, but it can be minimized by laminating the core. I'll just write here, eddy currents can be minimized by taking laminated core. But what is this laminated core? So, laminated core consists of thin metallic sheet. Sheets insulated from each other. Consists of thin metallic sheets insulated from each other by varnish instead of a solid single mass. Instead of solid single mass or single solid mass. Eddy currents can be minimized by taking laminated core, consists of thin metallic sheets insulated from each other by varnish instead of single solid mass. And you can see how these laminations are done in my previous video. I have put a picture in my video. Another important thing is the plane of this must be kept perpendicular to the direction of the current. The plane of the sheets should be kept perpendicular to the direction of the currents. Now, here the insulation provides high resistance, and hence eddy currents get minimized. Now, we have another question that has to be answered here. So, what are eddy currents? How are these minimized? Then mention 2 applications of eddy current. Now, applications of eddy current. Two applications are given. I can write 1 or 2 or 3. So, one is in electric brakes, or I can write magnetic braking in trains. So, the brakes which are used here works on the principle of eddy current. Now what happens here is the strong electromagnets are situated above the rails in some electrically powered trains. I'll write the explanation. Strong electromagnets are situated above the rails in some electrically powered trains. Electrically powered trains. Now what happens? You know what is electromagnet. So this acts as a magnet only when there is an electric current passing through the coil which is wound on that magnetic material. So now strong electromagnets are situated above the rails in semi-electrically powered trains. Now what happens? When the electromagnets are activated, or when the electromagnets become a magnet, when the electromagnets are activated, the eddy currents induced in the rails oppose the motion of the train. Now here electromagnets are situated above the rails. So when the electromagnets get activated, an eddy current gets induced in the rails and it opposes the motion of the train. Opposing the motion means just like putting a brake. As there are no mechanical linkages, the braking effect is smooth. So that is important. The braking effect is very smooth here. As there are no mechanical linkages, the braking effect is smooth. Okay, that is one advantage. It's asked to write 2. We can write another one. It's used in electromagnetic damping. Electromagnetic damping. So here this regarding this damping also we have learnt in the previous case how due to eddy current the damping takes place and slowly the oscillation stops. So this principle can be used in some galvanometers. So certain galvanometers will have a fixed core, and that core will be made up of non-magnetic metallic material. So there will be a metallic core, and when the coil oscillates, the eddy currents generated in the core oppose the motion and bring the coil to rest quickly. You can refer the previous video for more explanation about electromagnetic damping. Certain galvanometers have a fixed core made up of non-magnetic metallic material. Now what happens? When the coil oscillates, the eddy currents generated in the core oppose the motion oppose the motion and bring the coil to rest quickly. And bring the coil to rest quickly. These are some of the applications of eddy current. One is in magnetic braking in trains and another one is electromagnetic damping. There are some other applications like induction furnace, electric power meters. So if you have an analog power meter at your house, you might have observed a disc keeps rotating, and the disc rotates because of this eddy current, because the electric currents are induced in the disc by magnetic fields produced by sinusoidally varying current in the coil. So these are some of the other advantages or other applications of eddy current. Two I have written over here, the other two are, you can take down one as induction furnace and the second one as electric power meters. Hope you understood this question and answer.